Sharma, and this is a class demo for class 9th. So in this class we study laws of motion. So before going to laws of motion, I just wanna to clear out what is motion, or what do you understand by the word motion. We will start with an example. Let a box is placed at a position A. So this is an object. Okay, this object can be anything: box, ball, car, bus, train, you, anything. This is its position. Okay, so position is fixed at point A. Okay, now third quantity is we take is time. So if we take at time t is equals to 0, the box is at position A. Okay, now at time t is equals to 1 minute, box still remain at position A. Further, at time 2 minute, box still remains at position A. Okay, so what does that mean? That box is at rest, or box is not moving, right? Or box is not in motion, right? Similarly, we take the example of another box. This is the orange colored box. Now we take blue color box. Okay, so we have another box object, that is blue color box. Okay, and its position, we take his position also with blue color. Okay, so this box is at time t is equal to 0, this box is at A position. At time t is equals to 1 minute, this box is at B position. This B position can be anywhere. And at time t is equals to 2 minutes, this point is at C position. That means box is changing its position with respect to time. Then it said to be in motion. So any object changing its position with respect to time is in motion. Okay, so this is motion, when any object changes its position with respect to time. Okay, for example, we can say that there is a building from which we threw a ball. Okay, so at time is t is equal to 0, time at t is equals to 0, ball is at building. Then time t is equals to 1 minute, ball is somewhere in the mid, and let time t is equals to 0 minute, ball is at ground. Okay, so this ball is said to be in motion, or this ball is moving. So any object, it's if it's changing its position with respect to time, then it's called as in motion. Now our topic was laws of motion. So Newton defined 3 laws. Three laws of motion which every moving body follows. Every body in motion follows these 3 laws. So the first law is, before going to the statement, let's first understand what that law means. Okay, so according to the first law, what he said is, if a body is at rest, let's say this is at rest, then it can only be moved when there is an external force applied to it. Okay, or let a car moving in some direction, sorry, it's not that good, moving in some direction can only be stopped, it is moving in, if external force is applied to this. Let's not take the example of car. Or the second example is, an object is moving, okay, in this direction, can only be stopped by an external force. Okay, and third thing is, he said, is a ball, let's example of a ball which is moving in one direction can only be changed its direction when an external force is applied to it. So in the first law we study these 3 motions are rest, motion and the direction. Any object cannot change its state of motion and direction without an external force applied to it. So here's the law. You can say a state of motion and direction cannot be changed state of motion and direction can only be changed if there is some external force is applied. Okay, what is the state of motion here? What is the state of motion? A body can have 2 states of motion at any given of time. One is rest or one is moving. Okay, so either it is at rest or either it is in motion. So there are 2 states of motions for any object and direction. Okay, so state of motion and direction can only be changed if there is some external force is applied on the object. Okay, so this is your first law. We will discuss the example of the first law later. First we discuss all the laws. Second law. Second law of motion clearly state the mathematical formula of the between the force and the momentum. According to second law of motion, force applied on the external force applied on the body is directly proportional to change in momentum per unit change in time. Okay, so everybody knows it can also be represented as delta P by delta T. Here this delta is called as change, and this D, which we later on study, that it is also, it's called differentiation, which also mean change, small change we can say. Okay, so this is the second law. Okay, so from further if we break this down, we have F. For removing, F is directly proportional to dp by dt. For removing this directly proportional sign, we use a constant. Okay, so F is equals to k dp by dt. Okay, now we know what is the formula of P, that is momentum. What is the formula of P? That is mass into velocity. Okay, and now we know that this is the mass and this is the velocity. Mass of an object can be changed by motion. If you are throwing a ball towards any of your friend and then he throws back, or if you throwing the ball towards the wall and then it's bounced back, does the mass of the ball change? No, motion cannot change the mass of ball. Okay, so mass of ball cannot change, so it cannot be derived. Okay, so what we do is we take it as constant. So F is equals to km, we take it out of the change, and dv by dt. Okay, so I think we all know what this represents. This is the formula of acceleration. So F is equals to k m a. Okay, further we say that k is equals to further we assume if k is equals to 1, F is equals to m a. Hence the force. This is the relation. Second law depicts the relation between the external force and the momentum, which is F is directly proportional to the change in momentum per unit time, through which we derivate a formula for the external force. Okay, now we discuss the example later. Now the third law. What is third law say? Third law say that every action has equal and opposite reaction. Okay, so every action has equal and opposite reaction. This is the statement of third law. Okay, that means if you the best example for this is if recoiling of a gun. If you shoot a gun, okay, then bullet gets out of the gun, then you also feels a jitter in your shoulder. That is because the bullet moves forward and it have some reaction which you feel on your shoulder. Okay, also there is a example of boat. When you apply a force on a boat, it will slips back. Okay, so this is also example. Throwing a ball is an example, and there are so many examples of this law which we will discuss further in this class. That's it. Thank you.